Wow, big audience. Good morning, everyone. I'm Dave Weston, and I'm the New Zealand certification lead at a company called Merlin Labs. And hopefully I'll tell you a little bit about that as I go through today. As Gaetano said, you might recognize me from some other 146s, airwork altitude in New Zealand, and a small EASA design organization called Airbus. My whole kind of career has been design, certification, working with many of the people in this room. And before I get into it, I just want to say thank you to the CAA. I feel it privileged to be part of this organization. It's been my whole career pretty much, and definitely a privilege. And I guess Gaetano and Glenn trust me enough to get up and talk to you clever people. We'll see if I can keep their trust. So it is a design delegate seminar, 146's design delegates. So I thought I'd go full certification geek mode and talk about FAR 23, Amendment 64. Hopefully it won't be a super technical dive into 23. What I'd like to talk about is kind of our experience within Merlin, using FAR 23, specifically Amendment 64. I guess you could say we're an early adopter, so that always comes with some challenges. And slightly tongue-in-cheek, one of the FAA quotes from their original report that I guess initiated Amendment 64, double the safety at half the cost. I used that phrase at a conversation I had with the CAA recently, and I don't think I could tell if I was being serious or making a joke. But we'll see. I hate taking sound bites like the media do. I think it was followed by a statement along the lines of, it'll probably take a decade for that statement to be realized. So not quite there yet. Quick run through. I probably need to start to give you some context. So I'll describe a little bit about Merlin and what we do. A bit of a recap on FAR 23 Amendment 64. Again, not a deep dive, just the intent of that rule and what it's all about and why we're using it. I've taken a look at the original FAA report on why FAR 23 Amendment 64, and I guess tried to hold them accountable for some of the business case elements of that report. Why were they going to do this? What would be the benefits to the industry versus what we've experienced? Challenges. I think Gaetano and Jason both mentioned it. There are challenges in being early adopters and using this type of rule set. But there are huge opportunities as well, which is why Merlin is using this as our cert basis. And just a quick disclaimer, there are lots of challenges. This is kind of a snapshot. We're in the middle of an STC, so there are always challenges with an STC. And the CAA are hugely collaborative. So when I describe challenges here, I'm not pointing the finger in any direction. They're all cards on the table. And I guess it's just good for us to all be aware of them so we can kind of work as delegates, 146s with the CAA, all work together to kind of figure out how we work through that. As they say, the facts don't care about your feelings. So Merlin, who is Merlin? So Merlin is a startup company based out of Boston in the US. At its heart, it's a software company. Its initiation and its heart, like our core technology is software. And our objective, lots of companies talk about autonomy, and that can mean many different things, especially when it comes to aircraft and aviation. So currently, our goal, our objective is to create the most experienced pilot to reduce crew workload and reduce crew. We have obviously a long-term objective to achieve full autonomy. But achieving full autonomy in civil aviation, in controlled airspace with other non-autonomous aircraft, it is a very long-term goal, and it requires more than a well-designed aircraft and more than a certified aircraft. It requires a system level kind of change in the aviation system. So obviously that's our long-term goal, but our kind of ethos is crawl, walk, run. So our initial step is focusing on reducing crew workload, reducing crew numbers. So when I say autonomy, that's what I'm talking about in the context of what Merlin is trying to do. So what are we actually doing here in New Zealand? We are working in the civil aviation space. We're going through an STC certification program. So something very familiar to everyone in this room, I'm sure. Our kind of chosen target aircraft is the Textron or Cessna Caravan. So we are retrofitting our technology to this aircraft, so an existing type certified aircraft, using a New Zealand CAA STC, and we're going through a concurrent validation with the FAA. So it's a US-based company at its heart and its setup, but they have chosen strategically to come to New Zealand to do this certification. So they have this technology on a number of other aircraft, which I'll cover, but in terms of actually putting the kind of rubber to the road, they've come to New Zealand. They've chosen New Zealand for a number of reasons: a collaborative regulator, airspace availability, and I would say the general reputation for innovation in New Zealand. So there's 3 Merlin people here today. I'm one of them. The other 2 sitting at that table. So we've got Paul Wright. He's our design cert and software specialist, and Matt Pollock, senior avionics. So we've got cert, software, avionics. Now Merlin is not a 146. We operate very much like a 146, and a lot of our staff are ex-146 staff, and we're setting ourselves up very much like that, but we're not 146. So in order to gain an STC, we've partnered with existing 146s. So we've got Flight Structures, who are the lead certification 146. So they're essentially the primary interface between Merlin and the CAA, and they process all of the certification data for us. And then Becker, the Becker 146, which the only 146 in New Zealand with scope to certify software, obviously, which is key to what we're doing. So we work with Becker for the certification of our software, which is really core to what we're doing. So there's a real love triangle between Merlin, Becker, and Flight Structures. Oh, I can look down here. Don't have to look up there. So quick recap on FAR 23 Amendment 64. So at the bottom of the slide, you can see 2 hyperlinks there. One is to the FAA report that goes into full detail around why the FAA did Amendment 64. And then quite an excellent presentation, I think it was given at the Design Delegates Conference 2017. My memory serves me right, I think it was Dave Gill. So I've stolen some of that information, but I have credited it. So if you want to do a deep dive, you can pick up the presentation, have a look at those links. But overall, I would say the main objectives of Amendment 64 is to reduce the cost and complexity of doing certification, of gaining an STC, gaining a type certificate. I guess the whole point being that the emergence of new technologies that can enhance safety of aircraft is kind of racing ahead of how quickly certification could keep up. I mean, I think we all know, the hardware and the software you find on an aircraft is usually a decade behind what you can buy in Noel Lehman's, and that is part of that reason is because of the certification process. So trying to remove the complexity and time of that to enhance safety on aircraft at a lower cost. How is that done? So what the FAA have done is moved away from prescriptive rules. So, thou shalt have a red annunciator for a warning, through to performance-based rules. And a lot of the time, those performance-based rules are either embedded in industry standards, what we call ASTMs, or in our case, especially when you're coming up with new and novel features, the applicant can propose new means of compliance. FAR 23 breaks down the requirements based on the risk of the aircraft, a little bit like Gaetano or Jason perhaps was talking about in terms of the consequence. So the aircraft are broken down into 4 levels, primarily based on number of passengers. And the risk, I guess the robustness of the rules or the requirements of the rules are kind of catered to those. So I've just taken one snapshot that we might all be able to understand. System safety. So for the 4 levels in the rules, what is a catastrophic outcome? The probability of that happening is that range of numbers there, 10 to the minus 6 and 10 to the minus 9. So already they're kind of encoding some hard numbers into the rules to say your risk is this, therefore your consequence of failure and the probability associated with that varies depending on that risk. That's just one example that I thought throw some numbers out there, give you a sense. And the means of compliance, so this is kind of the nuts and bolts of where 146 is really kind of earn their keep, I would say. Means of compliance. So at a very high level, you have 3 options with FAR 23 Amendment 64. There's the industry standards, industry consensus standards that have been developed. It's basically a set of ASTM standards. If you read them, they're not too dissimilar from how the original FAR 23 rules read, but they are more performance-based, so they allow the applicant to kind of take alternative approaches rather than being precisely prescriptive. If you're working in Amendment 64, you do have the option just to skip straight back to Amendment 63 to use the old school rules. For some applicants, that is more efficient. It's a well-known, well-trodden set of rules. So sometimes that's the best way to go. Or, and this is the big or for Merlin, the applicant can propose means of compliance. Especially when you bring in technologies, functions maybe made for those kind of operations, you're kind of outside the envelope a little bit. So then the applicant has the ability to develop new requirements and new means of compliance. Now that can happen in all the rule sets, but I guess under FAR 2364, that's a large part of it. Now, coming back to the first point, Amendment 64 was all about reducing the cost to allow safety enhancements to get on the aircraft, to remove that kind of unintended consequence of safety being too expensive and too long, therefore you don't embody it. But what about autonomy? So autonomy and safety are not necessarily the same thing. So how are these rules going to work when we're trying to introduce autonomy, which is not necessarily purely a safety enhancement? It's new features, new functions, and are the rules going to be flexible enough and open enough to allow us to do that? And that's the challenge that Merlin's using, and that's why we're working in this area. So, some words now. So this is the bit where I went through, this is me trying to keep the FAA honest in terms of what I would call business case for FAR 23 Amendment 64. So they made a number of predictions around how this new rule set would benefit in terms of time and cost applicants. And this is the kind of really bread and butter stuff that you have to do when you're progressing an STC. Testing. So a huge part of the effort, the logistics, the time and cost, with certainly larger, more complex STCs, especially those that kind of affect flight operations, is test article for conformity. So your test article can be anything from a dog bone test on a piece of alloy through to the aircraft itself. And we all know how important conformity is with testing. No conformity, test's not valid. But there's a huge amount of cost and complexity with that, especially if your test articles are overseas, different locations, logistics of people availability at the right place at the right time. So the FAA proposed, rather than straight up conformity, that could be achieved through configuration management of test articles. Especially when your test articles in aircraft, that aircraft might be used to be a whole wide range of tests, ground tests, EMI tests on the ground, flight performance tests, stall tests, all sorts of tests. But you have to conform that. So Merlin, our approach has been what I would consider very standard, the way I've always done it on an STC. You produce your test articles under a Part 148 manufacturing organization. You take advantage of their conformity control process, their configuration control process. You do the same with the aircraft. You modify it in a 145 MRO. So a lot of those organizations, you get the process with the organization. And so whilst this was kind of a, hey, this is going to be an awesome thing that you can get from Amendment 64, I looked at it and thought, well, that's how we do STCs. That's how I've always done STCs. So, and that's how we're doing it at Merlin. So, yeah, tick in the box, already aligned with what we're doing. Next one, showing and finding of compliance, or what we might call SOC and FOC, or if you're doing a mod, the actual approval itself. So this was the FAA looking at how could they minimize their direct level of involvement in the technical reports, the testing, the analysis, all of that substantiation data that you prepare for an STC. And I guess their level of involvement being associated with a risk. And the risk in that scenario, they're talking about the risk of the data, the certification data being compromised. You know, FAA don't witness a test, the test isn't done properly, but they don't know it, then the data is invalid. So they're basically looking and saying, well, we'll address the risky areas, and for the non-risky areas, we'll allow the applicant. Well, that's what we already do in New Zealand 146s when we're processing STCs. It's not a new process. It's not, I guess, relatively new if your scale is like 40 years. But that's something we've been doing with STCs for a while now. We make an application. Some of the requirements are signed off internally by delegates, and some of them are signed off by the CAA directly, often based on risk. So again, FAA proposal, how do we do STCs in New Zealand? Pretty much the same thing. Video recordings in testing. So this is a little bit like the conformity thing, you know, test witnessing can be very logistically challenging. We're going to have a number of tests. We're going to have aircraft at Kerikeri. We're going to have aircraft in Mojave, like a certification test aircraft, software laboratories in Boston, systems bench tests, mock-ups of the cockpit spread all over the US, some in New Zealand. And we are doing a New Zealand STC. So, you know, test witnessing derives from the authority from the New Zealand CAA and design delegates. So we do have to think about that. Now, for us, certification testing is a while off. So this is kind of a little bit of a future consideration. But basically using video test videos as a way to mitigate all that travel, etc. So the FAA's position was use video recordings to witness tests unless there's a specific reason you shouldn't do that, which is a good way to approach it. So I can't really comment on this one too much in terms of what have Merlin done, because we're a little way off certification testing yet. Production manual, production as in manufacturing, production of aircraft. So FAA recognized there's a lot of startups, a lot of emerging companies wanting to develop aviation products, and it's no small task to create a production organization. So FAA are looking at providing guidance to these emerging organizations of what does a good production organization look like? What should your manual and your procedures look like to eliminate all of that noise? So great idea. Merlin NZ's approach is, again, back to, I would say, the tried and trusted. So first of all, we're not producing an aircraft. We're taking a type certified aircraft and retrofitting it with an STC. So that brings that risk down somewhat. And part production, as I said before, 148, aircraft modification 145. So for us, this isn't such a big deal. We're using certified New Zealand aviation organizations. So again, another tick in the box. What the FAA were expecting and what we're seeing as we're doing it, very, very similar. Organization handbook, so exposition. Put it on a shelf, never read it until there's an audit due. So the FAA recognized that there was a huge amount of variability in design expositions, in their design organizations, what they would call ODAs. And they specifically noted that the efficiency and the cost and the speed of an STC was directly related to the quality of the exposition, which I suppose what they mean is the quality of the procedures within the organization, not the actual paper document itself. You know, how efficient, how well organized are your procedures. And I think anyone who's worked in a 146 will know exactly what that means. Where you kind of live in with a manual that was created 20 years ago with lots of legacy data, and you get chances to improve it incrementally, but you really wish you could start again. So Merlin's approach to that, again, there's a real recurring theme. We're not a 146, but we've chosen to work with 146s. So they have established manuals, established procedures, and we have faith in them. It goes up and down, that faith, but we have faith in them to do that efficiently. So that's Becker and flight structures. Also, you know, as Merlin, we're structuring ourselves pretty much like a 146. So we're all ex-146 type staff. And within Merlin as well, we're also creating an SMS and a Part 135 certificate to operate it. So, yeah, all working within, bringing novel, new technology, but working within all the standard organizations and procedures within the New Zealand aviation system. Crikey, there's lots of these ones. Certification plan acceptance, that can take a while, getting your PSCP accepted. Quite often because you get held up on specific details, special conditions, equivalent level of safety. Now, in New Zealand, we very much always treat the PSCP like a live document. You know, you have a baseline and you evolve it as the design evolves. And that's very much the approach we're taking. And certainly within the context of Amendment 64, for us, there are lots of new and novel issues and requirements that we have to negotiate with the CAA. So the way we've approached that is really just, let's get a cert basis locked down, identify what all of those issues are, things that sit, some things which sit outside of the current rule basis, you know, functions on the aircraft that there are no rule provisions for, there are no guidance material for. So identify what they are, and as the design matures, so do issue papers and means of compliance for those issues. And that, so far, that's working very well. It allows you to lock down what you know and agree that, and identify what you don't yet know and work on that with a regulator. And the key is you can develop those requirements as your design develops. Because it's a performance-based rule, the performance requirements are very closely linked to the engineering, the thing that you're designing. So as that design evolves, you can have a lot more clarity on how should that thing perform safely. Harmonization of the rules. So this is where we come to the validation requirements. So at a high level, you could tick that box quite easily. You could say the rules that we're using are harmonized. Amendment 64 for the aircraft we're using is on the cert basis as FAR 23. It is the accepted cert basis in New Zealand. Tick the box, we've harmonized the rules. But I think we all know at a detail level, it's never quite that simple. So as I said, we're doing a concurrent validation with the FAA. So they're very much involved. I would say concurrent, there's probably a little bit of a lag, but for all intents and purposes, concurrent. So you're working with the New Zealand CAA and their counterparts in the FAA, and you're trying to harmonize, you're trying to come to the same conclusion that what we're doing is safe, we've got the right cert basis, all of these new and novel issues are being treated correctly, and we're thinking of all the right issues and all of the right risks. So getting that harmonized across two regulators at the same time, it is a challenge. It's always going to be a challenge when that many people are involved. But it's a challenge that we're working very openly and collaborative with the CA. It's something we all recognize was always going to be tricky. So there's lots of open, frank discussions about how we work through that. And that's one of the reasons why our company came to New Zealand, because they could see that open collaborative approach with the CAA. The STC process itself, so the way that New Zealand CAA process Amendment 64 STC is different to the way the FAA process it, in terms of how they do PSEPs and issue papers, etc. I won't go into the details of that, other than to say it is a different process. So when you're trying to get a validation, the question is it a validation? Are they accepting what New Zealand CAA are accepting? Or is it, no, you have to do it the way we do it as the FAA? That's what a validation is. Now that might sound a bit argumentative. I'm just trying to kind of paint the picture, worst case scenario. But yeah, when you have two different processes and one's trying to validate the other, there are going to be challenges. And that's something that we talk a lot to the CAA about, how we work with that, so that everyone in the conversation, the applicant, CAA, and the FAA kind of are satisfied that they're getting what they need out of that process. But, it's a challenge, and it's a challenge to time, and it's a challenge to cost, because these are all conversations that need to be happening. And those conversations take time and preparation, etc. And the last one is, there are some areas of our technology that are quite unique and specific, and maybe have not been developed in New Zealand before. Software is probably a big one. Flight control systems linked to advanced autopilots. Maybe not brand new systems, they're aircraft systems, but the CAA is working to get technical assistance from the FAA on some really specific topics, at the same time as trying to validate it. And quite often, I would imagine, the technical people providing that assistance are the same technical people doing the validation. So you kind of you're wanting people to split their brains a little bit. Today we're validating, tomorrow we're giving you technical assistance. So the overlap of those two processes is a bit of a challenge for us as well. So the challenges through Merlin's eyes, try to sum them up. Performance-based requirements are really cool. They really open the door for the applicant to design new novel stuff and then develop requirements that they can negotiate with the regulator based on what they're doing to the aircraft. So, from an engineering and a certification perspective, it's awesome. It's flexibility. But the flip side of that is, each time you develop a new requirement, you can't do it in isolation. So you have to take time to think like a regulator, research the prior rules and the ACs, and come up with what you think is a robust set of requirements. Then you have to present that to the regulator. And that process itself is very good. It's very collaborative. But again, it all takes time. It takes money, as opposed to there's a rule, there's the AC, there's a tried and trusted method. If we do it that way, everybody's happy. So, basically when there's less certainty, there's more work required to bring that certainty back. Concurrent design and certification. So when you're designing something and you have a set of certification requirements, those certification requirements absolutely inform the design. It's not the only thing that drives design, but it's one of the major drivers. So in our scenario now, whilst we're evolving our design and evolving our cert requirements at the same time, we're just carrying that risk that those two things are evolving at the same time. And if one goes in one direction and the other goes in another direction, you might find you're in a tricky spot. So it's basically a question of there's more unknowns. You're juggling more unknowns. You're juggling unknowns in the design world and unknowns in the certification world at the same time. On the flip side, that's what makes it so much fun. More back to like the 146 world. So when we're signing SOCs and when we're approving mods and signing FOCs under normal rule sets, the path through to compliance is very well known. If you're a delegate, the reason you're a delegate is because you have a lot of experience in doing that. Now we're saying, well, those requirements are performance-based and they might be unique to each project and they're somehow linked to the design concept that you have that day of the week. So it's a whole new kind of paradigm for delegates and SOCers in terms of what they're signing. The rules are not prescriptive. So how do you get to that point where you can say, actually, it has been satisfied, we have met the intent of the rule, when there's much less kind of black and white guidance for that. So we haven't got to that point yet. We're obviously a long way off doing any kind of final certification paperwork, but yeah, it's working in the kind of a much less defined arena. And maybe there's some training and familiarity that we will develop over time around how we work in that system. This is not a criticism of the CA whatsoever, but when you're working in an area where there's lots of unknowns, human behaviour is you tend to what you do know. So when we're faced with challenges in some of the really tricky areas of our STC around human factors, system safety, systems engineering and development assurance, there's a lot of tried and trusted methods and procedures that sit in FAR 25 for that stuff and in the prior FAR 23. And it's very easy when you're trying to create performance-based, you go in a big circle and you just end up back where you start and say, we're going to use the original requirements, or in fact, we're going to bring in some FAR 25 requirements. And yeah, it's, that's the kind of the human nature tendency when you want to find somewhere that that you can say that is the amount of risk that we're prepared to take. So that's kind of a human behavior thing, I would say, that does affect those negotiations when you're trying to talk about performance-based requirements, is the tendency, and it happens with the applicant as well, just to default back to what you know. Which, it's not always a bad thing. Sometimes that is the wise thing to do. But sometimes doing that won't get you the design concepts that you really want to put into the sky. And validation impact. I would imagine when the bilateral was created, it really didn't envisage working in this realm of performance-based requirements. So it's kind of no surprise that going through the validation process has caused some head scratching around how do we do this. Again, for the applicant, it usually eventuates as time and cost. So those are the challenges, but we're on top of all those challenges, and we're always very open with the CA and vice versa about what those challenges are, so that we can kind of work together. I've always kind of found that kind of collaborative approach it gets you to the end much quicker. But there are opportunities, like if it wasn't for Amendment 64, Merlin wouldn't be doing what we're doing the way we're doing it right now. We wouldn't be trying to take autonomy, pilot reduction, advanced autopilots, etc., through the kind of standard STC process if we didn't have this door of FAR 2364 open for us. Or if we didn't have that, it would be very, very difficult. So what are the benefits to us? So the nature of developing new requirements means you have to collaborate with the regulator. There's no other way to do it. Bespoke performance requirements. So there's a spelling mistake there. I'm not talking about a wheel with two spokes. It should be an E, bespoke. So the performance requirements, or your rule set effectively, is bespoke to your product. It's proprietary, so you end up with a proprietary cert basis that's very unique to your product. So for a lot of the emerging technologies and startups, that's just another very useful way to protect your IP, protect your certification. So that's really kind of a commercial outcome. History is really important. So the regulator opens the door to all these performance-based requirements, and you kind of start off looking and you're in a complete vacuum and you're like, where do I start? But you actually realize that what you really need to do is start with the historical rules, understand the intent of those rules, understand why they're there in the first place. Quite often the history of the rules, as they say, they're written in blood. They're usually there because something bad's happened, and we now have a rule to protect against that. ACs and policies. So you very often find you're not creating new requirements as such. what you're doing is looking at the existing requirements for existing aircraft types with a particular type of operation, and then you're saying what we're doing, what are the differences between that 777 doing an ILS landing in Queenstown and our Cessna Caravan? What are the differences, and what does the guidance say for this aircraft? And how is what we're doing different, and how can we kind of adapt the existing rules, the existing guidance to our scenario? And once you realize that, it's a bit of a light bulb moment, is, you're not reinventing or creating new requirements, you're just trying to, because the safety level you have to reach for Part 23, Part 25, that is not changing. That it isn't a reduction in safety level, it's just how you get there. So it's really adapting what we know and the intent of all of that history of information to the new aircraft types or the new technologies. It brings engineering and certification closer. I think that's already quite a normal thing in 146s in New Zealand. Often the people designing the product are the people doing the certification work. But this approach just reinforces that. And I think that's my last slide. The last one doesn't have any extra words other than this rule set has opened the door for Merlin, for new technologies, and a path to certify that in the normal civil certification world. Last but not least, just a snapshot of a few things we've been up to at Merlin. So it all started on a small kind of piston aircraft, I think it's called a Cozy. So all these aircraft have been operating in our experimental airspace that we have in Mojave, where things are a little bit different to experimental in New Zealand. So each of these aircraft, excluding the Herc, have actually been in operation with our autonomy system. So, we're doing certification here, but we've already had a few years proof of concept. And we've kind of gradually worked our way up through the aircraft types. So we've got the Cozy, the Caravan, which is what we're actually STC in, and Twin Otter, and future work to work with the US DoD on Hercules. So the technology we're building is not unique to an aircraft, it's a portable technology. And I just saw a big finish sign, which is cool because I've finished. So awesome. Now my marketing people say I have to put this as my last slide, so there you go. Is it questions now or? Yeah.
Yeah.
Dan?
Thanks, very interesting. Just this question popped in my head. Do you think you can control a crop duster on a crop dusting machine?
Sorry, I didn't quite hear that.
Top racing aircraft?
Yeah.
Cultural top racing?
Yep.
Do you think your technology will be able to do that someday?
Yeah.
That's flying below to the ground amongst, map obstacles.
I mean, our technology is takeoff to touchdown, so yeah. I mean, we haven't looked at that specific scenario, but I would see no reason why not. He says confidently.
Hey, you touched on quickly the notion of how you write these things when you have these bespoke certification basis.
Yeah.
And I'm interested in how that's going working with the FAA, because the example that's just occurred with the FAA is magnets and electric motor.
Okay.
So magnets spent the best part of 10 years working with the FAA to develop this comprehensive certification basis for electric motor, which the FAA will now just publish in public domain because the way the legislative system works.
Okay.
So it's no longer, now if I want to do an electric motor, I can just go and rip off what magnets spent 10 years doing. And I'm wondering whether you guys have encountered that it's one of the downsides of working with the FAA, or it has been a downside of working with the FAA. If you work with the ARSA, for instance, that having an agreed level of safety and that discussion about other papers in the ARSA system are confidential. So if you try and get the Airbus discussion papers, you can't get them because they're all locked away, whereas the FAA just publish them.
Right.
If you encounter that yet,
I mean, we haven't encountered that yet, but the reason is because we're fairly early in the process. So as far as certification goes, I guess we're coming to the end of what I would call the planning phase. So we're way off publishing any issue papers or any such things. I don't think I'll be able to answer your question directly, just purely because I don't know. I don't know how that's going to go with the FAA. Yeah. But no, it's a really good question, and thank you for that. I'll take that back because that's a good one. Yeah.